the integration of a function which are in standard form, like x to the power of n, and trigonometric functions sin x, cos x, and so on, and the functions which are in the form a to the power of x and 1 by x. So these type of functions, how to integrate, we learned in the previous lecture. Now we move on to the next concept. See, in integration, compared to the differentiation and integration, the part of integration will be bit tricky compared to the differentiation. So in differentiation, we have a chain rule. We have chain rule to solve the problems, which makes our problems, to solve our problems easy. That we don't have in integration. See, in integration we have many methods. So we have to opt slowly to each and every method. So later the practice gives clear understanding of this particular integration. Now we move on to the topic. In this particular lecture we learn how to find the integration which are in the form f of ax plus b. If suppose I consider this function, this one as a functions like f of x. If the particular x is replaced by ax plus b, if the particular function, if the particular x is replaced by ax plus b, then how to integrate those type of functions? See, if I have a function like f of ax plus b, which will be equal to ax plus b power n. To integrate this type of functions, I use the standard integration and I replace this ax plus b as some constant t. So that's called substitution method. Let ax plus b is equal to t. Differentiate with respect to t, then what we get? So both sides, if I differentiate, a into differentiation of x with respect to t is dx by dt, plus differentiation of constant is 0, which is equal to 1. Now a into dx will be equal to 1 into dt, and if I want to replace dx, then I can take it as dx as dt by a. So I want to find integration of this particular part. Now I am finding it. Integral ax plus b power n dx, which is equal to. Now I am changing total integration, the function in the form of t. The variable of integration I am changing. So I have to change everything in terms of t except the constants. Now ax plus b I substituted as t, so I substituted as t to the power of n, and the variable of integration is dx we have, so I have to replace this dx by dt, so dx can be replaced as dt by a. As a is a constant, I can take it as outside. Now I can apply the standard formula for this particular thing, so which is nothing but t to the power n plus 1 by n plus 1 plus some constant c. So now what we found here? What we found? This is nothing but integral of the given thing, and we just divided by a. So integral of ax plus b, is nothing but equal to t to the power of n plus 1. T, what is t? I have to replace the t, no? So which is nothing but 1 by a into ax plus b to the power of n plus 1 by n plus 1 plus c finally. So we have replaced the t value in terms of ax plus b, then we got. It's looking like the same, but the difference is we divided the particular integrand by a, which is nothing but the coefficient of x. Okay. So likewise, if I have a sine of ax plus b, what is the integration of sine of ax plus b? Its integral, which is nothing but minus cos ax plus b by coefficient of x. What I have, a coefficient of x as a, So I have to take a plus some constant c. Then what about a power x? And what about 1 by x? So if I have like a power x is replaced as a power ax plus b. So to avoid confusion, we consider it as an exponential function. So I have a to the power of x and I am replacing with some other variables. So I want to change this one as c to the power of ax plus b to avoid a confusion. Both these two may or may not be equal, right? So I took this one as c to the power of ax plus b. Now what is the integrand or integration of a power x? Integral a power x dx is equal to a to the power of x by log a. A to the power of x by log a, same thing. So we apply according to this. So a to the power of x, c to the power of x plus what we have? Ax plus b by log a. What is a? C into 1 by coefficient of x, which is nothing but a. Instead of saying this 1 by a, I can say it as f dash of x. F dash of x, this particular thing. Derivative of this particular thing. Right? If I have 1 by x plus b, so derivative of integration of 1 by x is log x. So if I want to find integral of 1 by x plus b, ax plus b dx, which is equal to logarithm of mod ax plus b by coefficient of x is a. So I mentioned here a and plus c. Don't forget to mention this plus c. See, after this, if the functions are like f of x by g of x, the function is like f of x by g of x, and the degree of f of x is more than or equal to g of x. So I am talking about degrees. Degree of g of x. So degree of f of x is greater than or equal to degree of g of x. We have to split those particular functions. So whatever I have numerator denominator form, no? So u by v still we didn't learn in this particular thing. We learn this in the next exercise. Before that, the basics we are going to learn, right? So degree of f of x is more than or equal to degree of g of x. In this particular cases, what we are going to do? So in these particular cases, we just divide the function f of x by g of x. So I perform division. F of x is divided by g of x. If I divide a function, I get here some quotient, that will be q of x, and finally some remainder r of x. Now we have to split this f of x by g of x as q of x plus r of x by g of x. So numerator by denominator can be written as quotient plus remainder by its denominator. So we have to perform the division. Suppose I have a function like x square plus 2 by x plus 1. So first I have to perform its division, and I get these all terms. Just substitute, split it. Later we have to apply its integration. Next, if the functions are like sine. See, previously if I want to find out a derivative of sine power 4x, so what I did, I used chain rule, right? I used chain rule and I found, which is nothing but 4 into sine cube x. It is not x, means x to the power of n formula applied. It is not x. I have performed its differentiation again. Now, if I have these type of forms, so how to do its its integration? We learned already differentiation. It's integration. So how to find integration of sine to the power of 4x dx, or integral of sine square x dx, or cos square x dx. These kind of things these particular things, how we are going to find out, that also we'll see. So we just split it up. We know only the functions derivative which are in the form of either sin x or cos x tan x, or in the form, now just we introduced, if the functions are in the form f of ax plus b, in the place of x I replace ax plus b. So that also we learn now. So if I have a power form, those particular things we have to convert in this particular form. Later we should apply its integration. So how we do? Cos square x dx. If I have cos square x dx, so if I can convert this cos square x dx as 1 plus cos 2x by 2 into dx. Now split, so I get integral 1 by 2 dx plus integral cos 2x by 2 dx. Now you see this is in the form ax plus b, where b is 0. See, if I have power 4, what should I write? Sin power 4x. Sin power 4x can be written as sin square x whole square. Now sin square x, so same form, I use 1 minus cos 2x by 2 the whole square. Still the powers, till we get the power as 1, we have to simplify and we get in the form such ax plus b. Till that we have to solve. If I have sin cube x, cos cube x, sin cube x formula, so we derive sin cube x formula from sin 3x and then we continue. Next, if I have a functions like the functions, find the integration of some 2x by root of 4x plus 1. 2x by root of 4x plus 1. So this, with the help of suitable operations, suitable product, multiplication, addition, subtraction, the numerator I convert in the form of the under root thing what I have, I convert in this form. So to do that, what I need actually, so I have here 2x, but it is in the form 4x plus 1. So this must be multiplied by 2. So what I do? Multiply by 2, 4x. If I multiply, definitely the function changes. So whenever I multiply, I have to divide. So multiplied by 2 and I divided by 2 outside. Right, I get root of 4x plus 1. Take dx. Next, still it is not in the form 4x plus 1. Right, what I can do? Add 1 and I subtract. Again, you don't change, right? I just split it like, so 1 by 2 integration of 4x plus 1 by root of 4x plus 1 dx minus integral 1 by 4x plus 1 and the root dx. So now this can be rewritten as integral of 4x plus 1 to the power 1 by 2. Right? Can be cancelled. We get here root of 4x plus 1. So power 1 by 2 dx. And minus integral of 4x plus 1 to the power of minus 1 by 2 dx. Now here we can apply, so which is nothing, ax plus b to the power of n. Right? In that way we can do these particular problems. Next, again trigonometry, if I go trigonometry, so trigonometry forms such as like product forms. Product, suppose I have a integral of sin mx into sin nx, which is nothing but sin x sin y, sin x sin y. So product forms, all product forms should be converted like sum. So how I can convert this particular thing into sum form? Multiply and divide. So if I multiply divide, I get 2 sin x into sin y, 2 sin x sin y, which is nothing but cos y minus cos x. Right? Do we remember that formula? Do we remember? Right, once again I will recall the formula. Sin 2 sin x sin y, I said wrong form. 2 sin x sin y can be written as cos x minus y minus cos x plus y. Cos x minus y minus cos x plus y. So I got in a summation form. right? So likewise, we have to simplify and then we should solve. Okay, so if I do some problems, we get better idea, we solve the problems. So take a problem now. Question number 1. Question number 1 given as, so 1, 2 can be done your own, right? So take third one. Find the antiderivatives of the following functions. So find antiderivative of the following functions. Take it as third one, second one, 4 e power x, 4 e power 3x plus 1. Third main, second, find antiderivative. So I take directly integral 4 e power 3x plus 1 dx. So can be written as 4 into integral e power 3x dx plus integral 1 into dx. Now it is in the form e power ax plus b. Fortunately here b value 0, right? Now what I can write, integral e power x is e power x divided by, see, it is not as the form x, it is the form ax plus b. So e power ax plus b by coefficient of x, which is nothing but 3, plus integration of dx, 1 dx is nothing but x plus 1 constant. Okay, after this, so 1 by root of 7 minus 2x, 1 by root of 7 minus 3x, sorry, 7 minus 2x, 1 by root of 7 minus 3x integral. So what I can do is, so I can convert in the form ax plus b power n. So how I can convert, can be written as root of 7 minus 3x can be written as 7 minus 3x whole power 1 by 2. So it is in denominator, so I get minus 1 by 2 dx. So to arrange this in proper way, we can write it as minus 3x plus 7 to the power of minus 1 by 2 dx. So in place of a, what I have, minus 3. In place of b, what I have, 7. So it is in the form ax plus b whole to the power of n. So whose integration is ax plus b power n plus 1. So minus 3x plus 7 whole power n plus 1. So minus 1 by 2 plus 1 by minus 1 by 2 plus 1 is actual its integration. But what I have to do next, into 1 by the coefficient of x. So coefficient of x means 1 by a, nothing but minus 3. Simplify it, we get the answer. So we get the answer here, minus 3x plus 7 whole power 1 by 2, which is nothing but 7 minus 3x under root divided by 1 by 2. So we get 2. So 2 by minus 3. So I get minus 2 by 3 into root of 7 minus 3x. Minus 2 by 3 into root of 7 minus 3x. Right? Okay. Next question. Problem. 5 into cosecant square 2 minus 7x. Right? That we can do directly. We can take it a tan square. So integral of tan square 2x minus 3 dx. So I have tan square. So in standard forms, I don't have any formula for tan square x. So I convert this tan square in the form of secant square using identity. So I can write it as secant square 2x minus 3 minus 1. Secant square x minus 1. So which is dx. Sorry, which is equal to tan square x, right? Now splitting, so integration of secant square 2x minus 3 dx minus integration of 1 dx. Now secant square x derivative I know. What is the secant square x derivative? Tan x. So, but in place of x we have ax plus b. So take it as ax plus b. Tan 2x minus 3 by, if it is in ax plus b, so I have to divide it with the quotient of x by 2. Minus integrand of 1. What is the integration of 1? X plus a constant c. Okay. Next, let's do the problems likewise and take a problem. Integration of e to the power of 3a log x e power 3a log x plus e power 3x log a, e power 3x log a. So I hope we have done these type of problems in a previous exercise. So how to simplify this? First, the whatever we have here, that transfer to the power of x. Then I get integral e power log x to the power of 3a plus e power log a to the power of 3x dx. And if I don't have any base is e. So whenever the base and the base of logarithm are equal, we get it as a power 3x as answer, the number as answer. So we get this particular thing as integral x to the power of 3a plus a to the power of 3x dx. So integral of x to the power of 3a dx plus integral of a to the power of 3x dx. So it is in the form x to the power of ax plus b. So x to the power of n, x to the power of n, so n plus 1. So x to the power of n plus 1, so 3a plus 1 plus 3a plus 1 plus a to the power of ax plus b. It's not a power x form, it is a to the power of ax plus b form. So a to the power of x integration is a to the power of x by log a, means you get here a to the power of 3x by log a into 1 by coefficient of x, a value, that is nothing but 3 plus some constant c. Okay. After this, sorry, see, x to the power of n, integration of x to the power of n is x to the power of n plus 1 by n plus 1. In place of n we have 3a, no? So we get in denominator 3a plus 1. This is our answer. Actually, if you want to simplify, you get it as 3 log a, nothing but log a cube. After this, integral secant square x into cosecant square x dx. Integral secant square x into cosecant square x dx. So we have a standard formula for secant square x alone and cosecant square x alone, but it is the product form. So how I can simplify? So I can simplify this one like taking its reciprocal. Secant square reciprocal is cos. So I convert this in that form, in the form of sin and cos. So I can write it as 1 by cos square x into 1 by sin square x dx. So whenever I see sin x into cos x, I can convert this particular thing in the form sin 2x, right? But for that I need 2. So here square, no? I have a 2 square. So I multiply 2 square for the denominator as well as for numerator. Then what I get? So integral 4 by 2 sin x cos x whole square, which is nothing but sine 2x whole square. So I get sine 2x whole square. Take 4 outside, I get integral. So 1 by sine 2x whole square. 1 by sine square x is nothing but cosecant square x dx. Integration of cosecant square x. It is not x, it is 2x. Integration of cosecant square x. Integration of cosecant square x is minus cot x. But in place of x I have 2x. So I get minus cot 2x by, because it is not x, no, it is 2x. So I get the coefficient of x in denominator plus some c. 2 1s are 2 2s are. So final answer minus 2 cot 2x plus c. Take next question. X by 2x minus 3. X by 2x minus 3, 11 second, integral x by 2x minus 3 dx. Right, this is in that form which is like 4x by something I have explained. So I have to convert this particular numerator in this form. Or see, I have a power of f of x. If it is in the form f of x by g of x, the power of f of x and the power of g of x, the degree of g of x, both are equal. So I can perform its division. So perform its division. I have x, divide x by 2x minus 3. So if I divide by 2x minus 3, what I get? Into 2x minus, into 1 by 2, no? 1 by 2. So 2x into 1 by 2 is x, minus 3 into 1 by 2 is 3 by 2. Right? Minus plus. When we gets cancelled, I get the remainder as 3 by 2. So the given thing is reduced in the form, because f of x by g of x can be written as q of x, coefficient, plus remainder by divider. So what we are using? Dividend, right? So integral quotient plus 3 by 2, remainder by the divisor, which is 2x minus 3 of dx. Now it is equal to integral 1 by 2 dx plus this 3 by 2 constant, I can take it outside. 3 by 2 into integral 1 by 2x minus 3 dx. So integral 1 by 2. So 1 by 2 also I can take outside. Integral 1 into dx is x. So you get x by 2 plus 3 by 2 into, it is in the form 1 by ax plus b. So 1 by ax plus b, integration is log mod ax plus b by a. The quotient of x is 2. So what is our final answer? X by 2 plus 3 by 4 into log mod 2x minus 3 plus constant. Here I started integration, so I get plus c. After this, 13 first one, similar with 13 first one, x cube by 2x plus 1. Workman first. Integral x by x plus 1 the whole square dx. X by x plus 1 the whole square dx. Okay. So in this particular forms, I said how to simplify f of x degree and g of x degree. If f of x degree is more than or equal to g of x degree, then we go for the division. But you can find here it's not happened. Okay. So whenever it is not happened, you just try to convert the numerator as denominator. So how can I do it? How I can do it? I can write it as integral of x plus 1 minus 1. X plus 1 minus 1 by x plus 1 whole square. X plus 1 minus 1 by x plus 1 whole square into dx. Right. Now integral of x plus 1 by x plus 1 the whole square dx minus integral 1 by x plus 1 square dx. See, x plus 1 and square will get cancelled. I get here 1 by x plus 1 dx minus integral. I can write it as x plus 1 to the power of minus 2 dx, which is nothing but ax plus b to the power of n. Now 1 by x plus 1, its integration is logarithm of mod x plus 1 by coefficient of x is 1, so I get 1 only, minus x plus 1 whole power minus 2. So x plus 1 power minus 2 plus 1 by minus 2 plus 1 plus a constant. So what is our final answer? Log x plus 1 minus, sorry, log x plus 1 we put it in a mod minus x plus 1 to the power of minus 1, which is nothing but 1 by x plus 1, right? So 1 by x plus 1, and I have here minus 2 plus 1, which gives answer minus 1. So minus 1 into minus plus c. Okay. X cube by 2x plus 1. X cube by dx. So I found here f of x degree is more than g of x degree. So I go for divide. So divide x cube by 2x plus 1. So it is x cube means the rest all are zeros. The rest we have to write in the form descending order, no, while doing division. So I have here x cube. So I don't have x square. So I put here 0x square. Next 0x plus some constant which is 0. Now I should start dividing. So I need x cube. So first divide x cube by 2x. I get 1 by 2 x square. So I get 1 by 2 x square. Multiply 1 by 2 x square into 2x is x cube plus 1 by 2 x square minus and minus, this will get cancelled. So I get minus 1 by 2 x square. So minus 1 by 2 x square by 2x. So I get minus 1 by 4x, multiply minus 1 by 4 into 2x minus 1 by 2 x square minus 1 by 4 x plus these two gets cancelled. I get 1 by 4x, again divide 1 by 4 by 2x, so I get 1 by 8. So 1 by 8 multiply 1 by 4x plus 1 by 8 minus and minus, these two gets cancelled. I get the remainder as minus 1 by 8. So f of x by g of x can be written as q of x plus r of x by g of x. So q of x represents quotient, r of x represents remainder, g of x represents divisor. So this can be written in that form. So I am converting that. We get integral q of x. What is q of x? 1 by 2 x square minus 1 by 4 x plus 1 by 8 plus r of x. What is the remainder? Minus 1 by 8 by g of x. What is the divisor? 2x plus 1 into the right. We get x. Now you can split it very easily. So integral of 1 by 2 x square dx, nothing but 1 by 2 into x to the power of 3 by 3 minus integral of 1 by 4 x dx, 1 by 4 into x square by 2 plus integral 1 by 8 dx. So 1 by 8 dx, 1 by 8 into x minus 1 by 8 into integral 1 by 2x plus 1. So integral 1 by 2x plus 1 log mod 2x plus 1 by quotient of x 2 plus some constant c. So what is our final answer? X cubed by 6 minus x square by 8 plus x by 8 minus log mod 2x plus 1 by 2 8s are 16 plus some constant c. Okay. Later 1 by 2x plus 3 under root minus 2x. Just multiply and divide. So we get answer. One by root 2x plus 3 minus root 2x. You just try to do it, we can solve it easily. So take a problem like x plus 1 by root 2x minus 1. X plus 1 by root 2x minus 1 or x into root 3x minus 2. X into root 3x minus 2. Similar way to the previous one of the problem, just we do it. 15-second x into integral x into root of 3x minus 2 dx. Product form. So whenever we have a product form, our first wish we have to convert the product form either in sum or difference. So how to do that? How to do? Just we have to get this particular thing in this form. So for that purpose, I have here x, I should get 3x. So multiply and divide by 3. 3x by 3 into root of 3x minus 2 dx. Right? So 1 by 3 I can take outside. Integral. I have just 3x but I need minus 2. So how I get minus 2? Just add and subtract 2, then we get. So I take 3x minus 2 plus 2 into root of 3x minus 2 dx. So now, so I get it as 1 by 3 integral. Multiply this one and this. 3x minus 2 into 3x minus 2 under root. 3x minus 2 means its power is 1. X power 1 into x power 1 by 2. X power 1 plus 1 by 2, which is nothing but 3x minus 2 power 1 plus 1 by 2, 3 by 2. Plus 2 into root of 3x minus 2, which is nothing but 3x minus 2 power 1 by 2 dx. Minus 2 power 3 by 2 dx plus 2 into integral 3x minus 2 power 1 by 2 dx. Okay, 1 by 3 into, it's in the form ax plus b power n, right? So can be written as ax minus 3x minus 2 power 3 by 2 plus 1 by 3 by 2 plus 1 into 1 by the coefficient of x, which is 3 plus 2 into 3x minus 2 power 1 by 2 plus 1 by 1 by 2 plus 1 into 1 by 3, the coefficient of x, plus the constant c. Now I have to simplify this particular part. What I get after simplifying that, I get 1 by 3 into 3 by 2 plus 1. So I can write it as 5 by 2. It becomes 2 by 5 into 3x minus 2 power 5 by 2 by 3. So I will say no, that one, plus 2 into 1 by 2 plus 1, 3 by 2. So if it goes to the numerator, it becomes 2 by 3 into 3x minus 2 power 3 by 2. Again by this, again 3 we have, that 3 plus c. So the final answer, multiply everything. So open this bracket. 2 by 3 5s are 15, 15 3s are 45. So 2 by 45 into 3x minus 2 power 5 by 2 plus 2 2s are 4 by 3 3s are 9, 9 3s are 27 into 3x minus 2 power 3 by 2 plus c. Okay, next question. So if I have a integration of a cos square x dx, integral cos square x dx. So once again I want to recall the multiple and submultiple in this formula. So I can write 1 minus cos 2x as 2 sin square x. So if I want to write only sin square x, this 2 can transpose to the left side. So I have sin square x, it will be 1 minus cos 2x. If it is sin square 2x, then it will be 1 minus cos 4x. If it is sin square 4x, then it will be 1 minus cos 8x. If it is 8, this will be 16. If it is 3, will be 6. So I have to multiply like that. If I have a 1 plus cos 2x by 2, which is equal to cos square x, right? Now if I have a cos square 2x, this becomes 4x. If it is 2, it's 4. If it is 3, it will be 6. If it is 4, this will be 8. Okay, now these applications. So I have a cos square x dx can be written as integral 1 minus cos 2x by 2 dx. So it is equal to 1 by 2 integral dx plus 1 by 2 integral cos 2x dx. So integral dx is x. So I get x by 2 plus 1 by 2 into cos 2x integration is sin 2x by quotient of x is 2 plus a constant. So our final answer, x by 2 plus 1 by 4 sin 2x plus some constant c. Next question. Integral cos to the power of 4 2x, integral cos to the power of 4 2x right. I have a cos to the power of 4, so I can write it as 1 minus, sorry, 1 second, cos power 4 2x can be written as cos square 2x whole square. So cos square x, just now we learn, if it is x, cos square x, we get 1 plus cos 2x by 2, but it is not x, it is 2x. So I get it as integral 1 plus cos twice, 2 times, we get cos 4x by 2 the whole square dx. Now simplification, integral 1 square 1 plus cos square 4x plus 2 into cos 4x by 2 square 4. Again I have here cos square 4x, I have to simplify it. So I get 1 by 4 common into integral 1, as dx. Integral 1 dx plus integral cos square 4x dx plus integral 2 into, so I can take 2 outside now, right? 2 into integral cos 4x dx. So I want to find out this one separately. If I take this as I, so I is equal to, so integral cos square 4x dx, so I can write it as integral 1 plus cos 8x by 2 dx. So I get it as 1 by 2 into integral dx plus 1 by 2 integral cos 8x dx. Okay, so this particular part, if I replace here after simplifying, that I get 1 by 2 integral dx is x plus 1 by 2 into integral cos 8x, which is equal to sin 8x by 8 plus a constant c. So that I value I am replacing in this particular place, so which is equal to 1 by 4 of integral dx x plus integral cos square 4x dx we got as 1 by 2 x plus sin 8x by 2 8s are 16 plus 2 into integral cos 4x, which is equal to sin 4x by 4 plus constant c. Now I want to simplify this particular thing. 1 by 4 into, take LCM, what will be the LCM? 2 twice. So LCM is 16x plus 8x plus sin 8x plus 8 sin 4x plus a constant c. So again I multiply 4 into 16 and I can write the answer as 16 plus 8, 24x plus sin 8x plus 8 sin 4x whole divided by 64 plus a constant c. So this is the integration of cos to the power of 4 to x. Next one, sin x into root 1 minus cos 2x. Sin x into root 1 minus cos 2x. Integral sin x into root of 1 minus cos 2x dx. It's the simplest one. 1 minus cos 2x can be written as 2 sin square x. Okay, so I get it as integral sin x into 2 sine square x and a root. So I get root 2. So integral root 2 into sine square x is sine x into sine x, sine square x dx. So now root 2 can be taken outside, root 2 into integral sine square x dx. So sine square x I cannot find, so I have to convert it in the form, so either cos ax plus b or sin ax plus b. For that purpose what I do, sine square x is equal to 1 minus cos 2x by 2 dx. So if I take 2 outside, I get root 2 by 2, 1 by root 2 into integral dx is x minus integral cos 2x is sin 2x by 2 plus c. So final answer, take 2 LCM, 1 by 2 root 2 into 2x minus sin 2x plus constant c. See, after this sin 4x by cos x dx. First one, integral, so sin 4x by cos x dx. So we can see this one as division form. So again we are searching for a method, still what we don't know. So I have to convert. So whenever I don't know, I have to convert. So sin 4x in terms of cos, is it possible? Let me check how it is possible. Sin 4x, if I use a formula, sin 4x can be written as 2 sin 2x into cos 2x by cos x dx. Again, sin 2x can be written in terms of cos, so I got a solution. So integral 2 into sin 2x can be written as 2 sin x cos x into cos 2x by cos x right? So cos x and cos x gets cancelled, so I can take 2 outside. So 2 into integral 2 sin x cos 2x dx. Now I got in a form of product form. So how can I simplify the product form? Product form can be simplified with the help of adding or subtracting, means by converting in the form addition or subtraction. So what I am seeing here, it is in the form 2 sin a cos b, so which is equal to sin a plus b plus sin a minus b. So I use this formula, then I get the answer as 2 into integral sin a plus b plus sin a minus b. So I get sin x plus 2x 3x plus sin x minus 2x minus x dx. Equal to 2 of integral sin 3x dx. Now sin of minus theta is minus sin theta, so I get minus sin x. So minus integral sin x dx. So my answer, 2 into integral sin 3x minus cos 3x by 3 minus integral sin x minus cos x plus a constant c. So our answer, minus 2 by 3 cos 3x plus cos x plus c. Okay, after this, integral sin to the power 6x. Sin power 6 x dx. Yeah, power is 6. So how can I simplify? Sin square x whole cube I can write, but sin cube x whole square also I can write. Which we feel is the easiest one. So we could sense sin cube x whole square will be the easiest one. So I take this one as integral sin cube x whole square dx. Now this sin cube x we have to express in the form of sin 3x. So what is sin 3x formula? Sin 3x is equal to 3 sin x minus 4 sin cube x. So from this I want sin cube x. So 4 sin cube x is equal to 3 sin x minus sin 3x. 3 sin x minus sin 3x. I want only sin cube, so 4 multiplying, just transfer, divides. So I can replace sin cube x as 1 by 4 into 3 sin x minus sin 3x. So replace it. Integral 1 by 4 3 sin x minus sin 3x whole square dx. So now apply formula a minus b whole square. So 1 by 4 whole square I get 1 by 16. Take it outside. Integral 3 sin x whole square 9 sin square x plus sin square 3x minus 2 into a into b, 2 into 3 6 sin x into sin 3x, sin x into sin 3x dx. You see here I have a sin square x and sin square 3x, so I have to convert. So I am doing that conversion. 1 by 16 into integral 9 of, so I can 9 of sin square x can be written as 1 minus cos 2x by 2 plus 1 minus cos 6x by 2. 6 can be written as 2 into 3. So I use 2 sin x sin 3x. I have 2 sin a sin b formula. What is 2 sin a sin b formula? Cos a minus b minus cos a plus b. So if I use that formula in this particular case, then I get minus 3 into cos a minus b, x minus 3x minus 2x, but cos of minus theta is plus cos theta, so I get minus cos 2x minus cos a plus b, cos x plus 3x, cos 4x dx. Okay, so later for the simplification, so I get this one as 1 by 16 into integral 9 by 2 dx minus, I take 9 by 2 common, 9 by 2 integral cos 2x plus, take 1 by 2 common, integral dx to dx and minus integral cos 6x by 2, so I can take 1 by 2 outside, so 1 by 2 cos 6x dx minus 3 integral cos 2x dx minus into minus plus integral cos 4x dx. Right, this I have to simplify. Right, let me do the simplification, which is equal to 1 by 16 into integral 9 by 2 dx is 9 by 2 x minus 9 by 2 into integral cos 2x dx is sin 2x by 2 plus 1 by 2 into integral dx is x minus 1 by 2 into cos 6x is sin 6x by 6 minus 3 into integral cos 2x sin 2x by 2 plus 3 is common for these two, so this one also has 3, so plus 3 into integral cos 4x is sin 4x by 4 plus arbitrary constant c. So after this, the simplest form we have to write. Further, take LCM 2, 4, 2, 12, 2, 4 is all or factors of 12. So my LCM we get the LCM as 12. So 1 by 16 into, take LCM as 12, 2 6 times 6 9s 54x minus 4 3 times 27 sin 2x plus 6x minus sin 6x minus 2 6 times 18 sin 2x plus 4 3 times 9 sin 4x plus c. Multiply 16 and 12. 16 12s will 6 are 72. We get denominator 192 into 54 plus 6. 60x minus 27 and 18. 27 30 45 sin 2x. After 2x write 4x. 9 sin 4x plus 9 sin 4x. After 4 you can write the rest. What we have, sin 6x plus a constant. So this gives the integration of sin to the power of 6x dx. Okay, after this, take next problem. Integral sin to the power of 4x into cos square x dx. Integral sin to the power 4x into cos square x. Cos square x dx. Right, this I have to do simplification. I have sin power 4x and the cos square x. So I can write the sin power 4x as sin square x into sin square x. So if I write it that way, so I get sin square x into sin square x into cos square x dx. Now I made this one as a group. So I know sin x into cos x is sin 2x, but for that I need 2. Actually sin x into cos x is not sin 2x. 2 sin x into cos x is sin 2x. So for that I need 2. So for the purpose I need to multiply by 2 and divide by 2. But I have here square also. So what I do, I multiply by 2 square, divide by 2 square. Then what I get, 2 square sin square x into cos square x. Nothing but 2 sin x cos x whole square. So 2 sin x cos x is sin 2x. So I get 1 by 4 integral sin square x can be written as 1 minus cos 2x by 2 into sin square 2x. So again, if I take this 2 outside, 1 by 8 integral 1 minus cos 2x into sin square x. Again, sin square x I have to simplify. So sin square x can be written as 1 minus cos 4x by 2 dx. Now again, these two can take out and multiply. 1 by 16 into integral 1 minus cos 2x into 1 minus cos 4x. 1 into 1, 1 minus cos 4x minus cos 2x plus cos 4x into cos 2x dx. Right? After this, how to do? You know, continue and solve. This one multiply and divide by 2. Now it is in the form 2 cos A cos B. 2 cos A cos B is nothing but equal to cos A plus B plus cos A minus B. Use that form and you simplify this later.